this fixed. Closer. What the fuck am I doing? I had to remove the extra project. I had two things open. This is a good song. This again. It's good volume. All right. Now I know what I'm going to be doing. All right. Accessing array elements using it does no bounds checking. Yeah, because we had proved this earlier. Oh. Oh, we actually get an issue here because oh, it actually still doesn't care? Return value ignored. That's it? Oh, so it just wants to use it? Give me the assert. There it is. Accessing some subscripts that ain't in range, yo. No discard, meaning we can't use it and not use it. Seems like. Or not get it without using it. Wow, dude, these lyrics are fantastic. Oh shit. Good? Okay. Uh-oh, yeah, invalid. Index for it can be non-const. Ooh, just runtime using at. So something dot at. Oh, okay. Standard classes for another element. It feels like this is being presented is actually going to be something better. That we prefer this. Boom. Comes. The array contains another one. The at function can be used. So we can do at something. Should have done that first. Have the function so that the program actually works. Runtime. Assert again. Oh, it throws an exception. Dog. Yep, throws exception. That's what we saw. Yep. 3 is. The at, it throws an exception of standard type out of range. That's what we saw. Yep. It's not handled. The program is terminated. But there are ways of handling it. Okay. Who is the voice? No. No. Oh, that's why she's recommended. Instead of accessing one that's invalid and then throwing an exception. Well, the interesting part here is this. That this is used over at because it's better to do bounds checking prior to indexing. But it doesn't even do bounds checking. So it seems like that's not actually helping. Indexing with a const expression signed int. Which kind of sucks. That's because that's a constant expression. Those are just three of the literal. The issue was using an official signed. Sorry. Oh, voice is fucked up. Whoops. What's today? Saturday, right? Thank God. Excuse me. Makes sense. But it's a non-const expression and signed. Uh-oh. Hmm. Sorry. Yeah, because it's not checking at const expression time. Yeah, it makes sense. I mean, it's just like any regular conversion. And mine will treat it as an error and prevent compilation. Yup. Really? Create a standard size t and initialize it, and then oh my god. Okay. The criminal comes out. The guy, the person behind it all. It was the C-style array all along. Initialize a standard vector with these values. Hello. Okay. Please. Print the length. Wrong thing. With index 1 using the subscript and the at. Makes sense, yeah. And we could do no insert, bro. Oh. Can't do at. Makes sense. Could do it different ways. Oh, and also true because duh, the fucking number itself is a const expression. Size type, let's see. So size type is the data type that stores a particular array's size. And if not explicitly specified because of a custom allocator, I believe it is an alias for a standard size t, which means it should be a size t, which means on my 64-bit system it should be an alias for a long, an unsigned long. It should be defining technically to a standard size t, which is, I guess, defined somewhere else in the standard library, and it is an unsigned long. Which functions to get the length? I mean, we have dot size, and I think there's probably also dot length as well for maybe a string view, but there's at least size. Because you could also do standard size and then pass it in that way too. Cool. Passing a standard vector. Yeah, we've already done some of this in my little test examples, const references and whatnot. Makes sense. The element type is part of the information, therefore, meaning we're going to need to specify the type as the parameter. Yep, exactly. It expects some, we can't pass other times. So we have standard vector something. We have doubles and ints. Can't pass the doubles. Makes sense. Plus, references in general have to match the same type anyway. Makes sense. Might try to use class symbol argument deduction. I mean, we could use a class template, but not here. Yes, exactly. Yeah, so we could do, for example, Cool. And yes, I agree with this being a good place to use class templates and function templates. Really, function templates, because we're talking about like a uniform type that we want to do stuff to and handle for a bunch of things. It's not a specific object like a monster or something. It's just a generic thing. Like we want to be able to print whatever. Maybe we want to print the name of anything. Well, as long as it has a name, boom, we can put it in. Yep, primes and double. Yep. Going a little ego mode. Here we go. Oh fuck! My hand touched. I'll take up maybe 80% correct form for 3. Not too terrible. It's fine on a fucked up stomach. Yep. Here's the important part. Yep. Yep. Oh. I was thinking about something like this earlier where I wanted to see if we could pass something and only pass things that have a main, like a certain, like a certain member function. Kind of like a cast. Like a check to see if it has that. printing the second element there, by the way, but it's fine. Excuse me. Yeah, that makes sense. Yeah. So I'm not sure how to actually check to make sure it's a valid type. Just because it has an overloaded bracket doesn't necessarily mean a bracket operator doesn't mean that it's a valid type that we want to do this for. Oh, we could just assert that. What? Well, yeah. If it doesn't have that, then it's not valid. I mean, it could. I mean, in this case, we could just check to make sure that the size is greater than 3. We could assert that the size is greater than 3. Yeah, 3 is not valid. Too short, bucko. That way we can check it at compile time. Gotcha. Oh, that's nice, because then it can actually check to see what the potential values would be. Oh, that could be good. Yeah, the compiler is checking to see if the static assert stays valid. Avoid writing functions that, well, yeah, makes sense. Don't just pass in one that prints a certain length. Print one that does a certain length that the user sets if it's valid. Hmm. Okay. Function that takes 2, a standard vector and an index. So if we an index of or an array of size 5 has an index of max size 4. So the size must be greater than or equal to index plus 1. It's empty, it's going to give a 1. No, it doesn't. Well, I'm surprised. 5, if there are 5 elements, the most it can do is 4. Or we could say that the index is less than or equal to, or index is less than the size, right? It's got to be. The size is 5, it has to be less, right? Isn't that easier? I mean, excuse me. True, it's narrowing. I mean, oh, oops. 2 is valid. 5 is invalid. 0 is valid. -1 is not. Oh, well. Oh, true. Oh, wait. Oh, this is the error. He's doing the catch first. There it is. I honestly should do that first. Does it matter? I mean, if we only want it to happen here, maybe there are other cases. I think it works either way, honestly. He did a static cast on it like that. Same as what I did. Cool. Yeah, I'll take it. Move semantics. Oh, is that how move semantics work? So if we have a standard vector of size 3, okay, so it has 0, 1, and 2, indexes 0, 1, and 2, and let's say that we clear the one in the middle, we clear the first index, so 0, 1, 2, we clear 1, so now we have 0, and, well, so the second index, now we have 0 and 2. Well, what happens when we clear the 1? Where does the 2 go? Does it get copied somewhere else to then move there, or does it just get moved over? When we pass a standard vector, oh, and if we're passing a standard vector by value, how does that work too? Are there other optimizations where we just move it? Meaning we just move it to where this other thing is, but or just say that that thing is looking where the standard vector is instead? Yeah, you would think it would be an expensive copy. Before returning a standard vector, copy semantics. Yep, 2 copies. So a program defined type with a copy constructor supports copy semantics then, huh? Yeah, duh. Well, yeah. Elision, copy elision. Because in this case, we're initializing this guy, and then we are copying it into here instead of potentially just moving the value in. Okay. More later. Okay. Because standard vector uses unsigned length, you get narrowing conversions when passing non-const expressions signed values. These as subscript. Excuse me. Bum, bum, bum. Yep. Not sure. Well, move semantics are the rules that govern. Well, fuck. Those are copy semantics, right? Move semantics are rules that describe how data may be copied and moved, i.e., copy semantics. For example, copy semantics are the rules that govern how an object is copied to another, and the object's is copied to another object. These rules might be implemented in a copy constructor. Two ways. One, list initialize a standard vector with 5 elements, values we want, or if we want a 5 element empty vector, direct initialize it to 5 as the value, creating a vector with size length 5 with each element value initialized to 0 or blank, depending on the data type. 85. Declare static member variables by hold. I mean, we normally just define them outside the class, right? But must they be defined outside the class? Starting them with the static keyword. Letting it. Well, is it just a warning? Oh, it actually did succeed. Okay. letting us not preferred call the static member function on the class object, or call it by resolving the class's scope, like this. Instead of use friend functions conservatively use friend functions when needed. Like when decluttering, well, like if a function isn't needed within the class body, but always uses the class, and accessing private data members grants notable efficiency, or noticeable efficiency gains. Or if the syntax is better, including the class object in the parenthesis or as an argument instead of the implicit object. Test x instead of x.test. Careful, since this breaks encapsulation. Something that isn't of the class is using its private protected data members. The hidden this pointer is a pointer that is implicitly included in class member function parameters, automatically passing the class object to its member functions, letting us use them without explicitly passing the object to its class's member functions. This lets us use shorthand data member names instead of using the arrow operator on this. Access the member functions through the pointer. Explicit is used to prevent to disallow copy initialization and to disallow implicit conversions. We use this for constructors that are able to take one argument, since the likelihood to be type safe and prevent potentially unsafe implicit conversions. Find a const member function by including const between the parentheses and braces, like void test const. The copy constructor is used to create or to initialize a class object with another class object of the same class type. I.e., yeah, that's it. The constructor initializer list is used to initialize its data members with its constructor arguments, with its seed arguments in constructor calls. This lets us use list initialization to initialize class object instead of setter functions for each data member, unless a bulk setter exists. Encapsulation involves combining separate objects under one larger object umbrella by fingers under a hand inside a hand object, class object. And data hiding, where private protected class data members are hidden from the public, and the values of which set and acquired via setter, public, setter, and getter functions. Robust type defs. Since the implementation change not having to update code that uses the public interface. Class template argument deduction guide. Syntax that tells the compiler what class constructor arguments to look for when using it should treat class template calls. I'll hold. Oh, there it is. Nope. No? No? Yeah, I don't know. Okay. A function template for max. I mean, we want to do the same type, right? Is it that easy? Hold. Get max. Return. If x is greater than y, return x. Otherwise, return y. I think that's it. Oh, my eyes are failing me. I stayed up too late again. Function template is a function includes a preceding clause that makes compiler generate a separate version of it for each set of unique call argument combinations types. Those instantiated versions will be called by the callers. Compiler chooses the correct overloaded function by determining the best match for each call. If a best match doesn't exist, the compiler will perform implicit conversions to yield it. If an implicit conversion yields more than one best match, we get an ambiguous match compiler error. Function overloading. Creating multiple versions of a function with the same identifier but different parameter combinations. The best match overload will be called by each function call unless it's an ambiguous call. Unless the call argument yields an ambiguous match. A type alias is an alias for another data type where we can use a custom name to refer to it. Name for type def. Type def and using both work like this. Narrowing conversion is is the process by which, is the phenomenon when data of type A is converted to type B, where type B can't represent all values of type A, can be which is a potentially unsafe conversion. Avoid them because they can potentially lead to data loss, like a double to an int conversion. 61. Auto as the data type, return type, or argument type looks a bit different since it's a function template shorthand option. The data type will deduce from the initializer or returned values data type. An implicit conversion is occurs when converting data from one type to another, occurs when passing data of type A to something expecting type B. Function parameter, assigning, initializing to, or initializing an object. So the compiler conversion to yield well, not even the comment type, to the final type, which may be unsafe. Okay, we'll copy this. Let's turn the fan down. Let me make sure my AC is kicking because I'm about to go to bed. Okie doker. Hmm. Deep copy. Ooh. Move from the vector. I don't know how that works. We'll see. Well, yeah, for changing it, just don't do a const reference. Makes sense. Yep. True. Negative values wrap around, which are still undefined. Yeah, the point is we're getting undefined behavior here. Yeah, we know it's underflow. Yeah. Okay, well, I mean, I still get errors here. The point is that we're getting undefined behavior for using it. Apparently, it's not always just underflow. So far. Move semantics. Yeah, I don't know what it actually is. Move semantics allow transferring ownership of resources without deep copying. Oh, shit. Meaning actually taking objects X and Y and moving the value, or well, and saying that Y owns the value now instead of X. So if we have V2 and we standard move it, V2 is stealing the memory buffer from V1, and then V1 is empty but valid. Meaning that, hey, this identifier refers to this piece of memory with value. Now this identifier instead is referring to it and popping V1 out of there. Noted. Okay. Creating a vector 5 ints, cool. Yeah, but we still need to put static inside the function. Are declared, but must also be defined outside once in the source file. Oh. Well, declaration inside. Oh, whoops, sorry. This is my variable. My bad. Unless we make them inline, we do have to define them outside. Sorry, I was thinking member variables. I'm just tired. Used for operator overloading. No, it's not. It seems like it's not a big deal if it's the an overload that's using it and not a function where we could. Seems like it's probably helpful instead of having to use getters all the time. Yeah, it doesn't have it for friend or non or static functions. Hey, why would we want a mutable const? What? Oh, or is the point that we get to call it with a const member variable, but to change a non-const member variable? I guess that's the point. It's saying no member variables. Yep. Unless we did explicit there, then it would disallow the copy, but it's fine. Well, I guess the point here is we only need that. What? Oh, we don't even say it, huh? Oh, we don't even say using. We just say that to that. Okay. I didn't look at them too hard. Okay. And it doesn't even need to say using. Okay. Can be defined wherever. Struct. Yep. True, but you should define it, brother. Okay. I'll take it. It's a bit glazing. I don't think I've mastered shit, but we'll see. My well, can't really rename this if I haven't uploaded it yet, huh? Next steps here. I've updated my whiteboard so that well, what do you? I guess I don't even want to see it. I've updated my whiteboard, so I'm gonna do 3 things now. So, excuse me. 1, I'm learning C++ every day. But 2, I'm also working on this little VoIP voice over internet protocol mage game, and I'm making it multiplayer now, and I want to ship it, just as like a little test idea. And then I also, it's better to do it sooner than later. I need to spend my other free time doing other Unreal, Blueprint, and C++ tutorials just to see how other people actually use C++ and Unreal. Because at this point, I mean, I'm starting to at least get like a tiny grasp, at least a start of a grasp to do something in C++. Like, I think I could do my Liar's Bar copy right now. I'm pretty sure I could do it all. I'm confident. And at least for how I already have it in my head, yeah, I can do this for sure. Probably take me maybe a day. Yeah, I think I could do it in a day. I could do it in a day for sure. But I'm going to see how people actually use C++ in Unreal, because it seems like Unreal is a wrapper for C++, meaning that you use the version of C++ that Unreal does. So you don't just use C++, you use Unreal's like hybrid kind of language, where you don't make a class, you make a U class, and it has U properties, and it has all these specific things inside it that are C++, but Unreal C++, which is unique, which means I think I need to probably start spending time with that to, one, identify if there's anything else in C++ I need to be more familiar with before going on, and two, to just start building hours in that. And then once I see how people do it and when they do it for core systems, then boom, I can become better in Unreal. Because I want to make like a dark and darker type of game. My main ideas now are make a Liar's Bar clone, ship my VoIP multiplayer game, but then have like a dark and darker kind of VR game. And I need to get Oculus and whatnot, Unreal VR software development kits, SDKs, so I can, I guess, just use that. I'm not really sure exactly what the difference is, but make the VR game so that you can sit down IRL, and when you do, rest, and maybe you can polish off your armor and do stuff to repair it or improve it or something like that. I'm not exactly sure. Or prep it, or like make it so that enemies are I'm not really sure, but I want to do something where if you sit down you can do stuff. Like for spellcasters, sure, you could just sit down, and maybe the ambience is just nice and you can just sit down and listen to what's going on, just like a wizard. There's not really anything to do there, but in the game there are at least emotes. Emotes are like little like cosmetic visuals that your character did, like could be smoking a pipe or eating meat or something like that. But if you're in VR, your hands move around, so maybe you need something to do, actually. I think that would be a good idea. And maybe 2 maps, a boss per map, and then 10 unique mobs per map, something like that, with custom movesets. And I'm going to need to get back into rigging at some point, and then start doing some quadrupeds so that we can have not just bipedal enemies. But the plans are in order, though, so now I'm going to start doing 3 things instead of 2. So still doing Unreal in the free time, but also doing the Unreal C++ tutorials. It's like C++ for blueprinters, just to test it out. And because I think I regret not starting with tutorials earlier in Unreal. Like I just started trying to do stuff from scratch, but it's nicer if I also get to see how other people do it. Maybe that biases me towards that, but I think in reality, it's probably the case that other people are actually doing the correct answers. Like if you were teaching me math and you're like, hey Ethan, blah blah blah, this plus this, blah blah blah, whatever, and then I was given an assignment, or well, actually you just asked me from the scratch, like how much is this and this? If I gave you 3 sticks and I give you 2 more sticks, how many do you have? Blah blah blah. Write it down. Maybe it would be helpful for me to watch somebody else write it down and start first, like the teacher in the front of the class, and then I start. Maybe it biases me, but I don't know. It seems like that's a good idea. Like having made an inventory before in Unreal, a grid-based one that was buggy in the end, but whatever, because it also was in the video too, but I probably screwed something or other up. Before doing my inventory, I followed that tutorial, and I did it for like, I don't know, 4 or 5 hours. It came out okay, cool. But doing that taught me when I gained muscle memory for when to use something. Even though I was following instructions, I was still having to find it and do it myself, technically. I wasn't copying and pasting anything. I was following instructions. And then when I made my own inventory, I was able to do it completely free from anybody's help or intervention or anything, just because I already had the answers built in the brain. So I think doing a tutorial just to see how something is done is very helpful, instead of like wasting time trying to figure it out from scratch, unless I can already make the progress to do that. So I think so. I think that makes sense. Cool. All right, more tomorrow.